Let's solve problem 5.26 for Microelectronic Circuits 8th edition by Sedra and Smith. We're basically given this table and it has a bunch of different cases where we're given source, gate, and drain voltage, and we want to solve for the rest of the table given that Vt is equal to 1 volt. And we have a special tidbit here. If we encounter a case for which the voltage from drain to source is negative, we should exchange the drain and source before solving the problem because the MOSFET is a symmetric device. So before we start solving, I'm just going to identify how we can solve for each of these values. So the voltage from gate to source, well, that's just simply equal to voltage at the gate minus the voltage at the source. We can solve for V over drive by subtracting the voltage from gate to source by threshold voltage. And the voltage from drain to source is just the voltage from the drain minus the voltage from the source. And as far as region of operation, if the voltage from drain to source is greater than or equal to V over drive, that means we're in the saturation region. But if VDS is less than V over drive, then we are in the triode region. So that's really all the equations and information we need to start solving. So for case A, I'm going to solve for VGS is equal to VG, 1 volt, minus VS, 1 volt, gate 0 volts. That means V over drive is equal to 0 minus 1, because V threshold is 1 volt, so we get negative 1. VDS is equal to 2 minus 1, which is 1. And this is, actually this is an interesting case. So V over drive is negative, which means we're in the cutoff region. So I guess I need to identify the third region, which we don't really use that much, but if your overdrive voltage is less than 0, you're actually operating in the cutoff region. So we usually don't deal with that region much because there's not much use in using a MOSFET in cutoff, but it does exist. So that first region is actually cutoff. Okay, case B. So voltage from gate to source is 2.5 minus 1, and that's 1.5 volts, which means our overdrive is 1.5 minus 1 equals 0.5. So we have a positive V overdrive, so we're good here. VDS is equal to voltage at drain is 2 minus voltage at source is 1, so we get 1 volt. And then this is greater than V overdrive. So we should be in saturation. Okay, let's do case C. So VGS is equal to 2.5 minus 1 again. 1.5. The overdrive is equal to 1.5 minus 1 to get 0.5 again. And VDS is equal to 1.5 minus 1 to get 0.5. So we get that VDS is equal to V overdrive, so we're in saturation. Okay, let's solve case D. So I already noticed that voltage at drain is less than voltage at source, which means we're going to get a negative value. So according to the problem, we need to exchange the drain and source. So that means that voltage at drain will now be 1 volt and voltage at source will be 0. So I'm just going to kind of make that note here. Okay. So that means voltage from gate to source is 1.5 minus 0. So that would be, or yeah, that would be 1.5, okay. Which means V over drive is equal to 1.5 minus 1, which is equal to 0.5. And then VDS is equal to 1 minus 0, which is equal to 1. And this is greater than V over drive. So we are in saturation once again. Okay, I think at this point I'm just going to kind of verbally calculate these. So for case E, VGS is equal to 2.5 minus 0, 2.5. V over drive is VGS minus VT, so 2.5 minus 1, 1.5. And then VDS is 1 minus 0. Now for case D, or this is case E, VDS is less than V over drive, so we're going to be in triode region. Okay, so case F, VG minus VS is 1 minus 1, so we have 0. That means V over drive is negative 1, because it's 0 minus 1, and VDS is also 0. So again, we have this negative overdrive voltage, which means we are in the cutoff region. Okay, so we have, for case G, VGS is 0 minus a negative 1, so it becomes a positive 1. So V overdrive is 1 minus 1, 0, and VDS is 0 minus a negative 1. You get a positive 1 for there. And then we have that VDS is greater than V overdrive, so this is saturation. Okay, for VGS we have 0 minus a negative 1.5, which becomes positive 1.5, which means V overdrive is 1.5 minus 1, which is 0.5. VDS is 0 minus negative 1.5, that is 1.5. This is greater than V overdrive, so we are once again in saturation. Okay, for case I, we have VGS is 0 minus a negative 1, so we get a positive 1. V overdrive is 1 minus 1, which is 0. VDS is positive 1 minus negative 1, which becomes 1 plus 1, so we get 2. This is greater than V overdrive, so we're in saturation. Lastly, we have case J. VGS is 2 minus 0.5, which is 1.5. V overdrive is 1.5 minus 1. And VDS is 0.5 minus 0.5, so 0. And this is less than V overdrive. We're in the triode region. And that completes the table. Thank you for watching my video. I hope you enjoyed it. For any questions or video suggestions, feel free to contact me in the comments or by my email. Thank you and have a great day.